one of the strategies that I am going to suggest again and again and again during practice is this notion of, for effective practice, you should be able to rephrase new questions, rephrase the question or frame new questions. This is one way to build anticipation for the type of questions that show up in gate exam. Also kind of strengthen what you learned. Okay, sort of like kind of reinforcement learning, right? You kind of play with yourself and then reinforce what you know by trying out different alternatives. Okay, so let's do a small exercise. Let's quickly ask what kind of questions could they have asked here instead of the question in the slide. Okay, this is a hard question. What else actually could they have asked? What do you think is a reasonable gate question? Can you rephrase, or can you pose similar based on this concept? Can you pose other types, few examples of gate questions? Okay, instead of asking this, they can ask this, or instead of giving this, they could have given this and then asked this. Can you give some couple of alternatives for what is given here? Okay, this is a rephrase exercise or framing exercise. Okay, frequency response of h of omega. Okay, so transfer function magnitude and phase response is given. We have to find output, or when the output becomes 0. Okay, for step response. So of course we discuss some strategies for this. This is first is find the form of h of omega. Second is once you know h of omega, or h of j omega, however you want to call it, let's to be consistent with notation in the page, find h of j omega. Second is find y of s. This is just h of s, x of s. Okay, and then if you take inverse Laplace transform, you can find y of t and set that to 0, find that time. Okay, so notice you essentially know this. This is given to be 1 over s, step response. So you also know this. And if you take inverse Laplace transforms, you can get this and set that to 0. He also said, of course, this is one of the hardest questions in the paper. Okay, and in fact, the hardest step is this inverse problem here, that is finding h of j omega from this. Part of the answer is perhaps if we know the standard things. Okay, this is all pass filter. What is how does the transfer function kind of look for that? If we had some info on that, then this inverse problem is actually very, very easy. Okay, so one of the questions is basically how does low pass filter look? How does high pass filter look? How does all pass filter, band pass, band notch filters, on all that look? That we have to, if we kind of know that, if we have that in our prior knowledge, then this step also kind of becomes easier. Okay, so what makes this problem interesting is it connects Fourier transforms, okay, or frequency response with some basic Laplace transforms and all that. And then there is also time response. Okay, now there is a lot to learn from this question. First is, can you rephrase? Okay, let me get you started with this. So I chose this example because there are multiple subparts and each part is each part is this thing. Okay, can they just ask for what is y of t? Instead of setting it to 0 and something like that, can they ask for what is y of t? Notice that is slightly, that will make this easier, right? Can you specify other things? Of course, they could have asked you for what is y of s. They could have asked you for what is h of s or h of j omega. What is this? Each of this could have made individual questions. Okay, now can you suggest more examples on this? Yeah, now we get a nice answer in the chat. Instead of giving this information, they could have actually give h of s instead. Directly give h of s. That would have made the problem easier. In fact, most of the steps would have made the problem easier. Just find y of t, it's easier because you don't have to substitute, find where the time, the time point where it is 0. You have to solve one more equation here, no easier. Finding y of s is easier compared to the given question. Finding h of s is easier to compared to the given question. Or, avoid this hard step, inferring this h of s from the frequency response. Avoid that step, directly give h of s. Again, that would have made it easier. Notice all of this are, we have listed down, 4 alternatives. All of them happen to be easier versions. All are easy. See, this gate question, what is given might have been very, very hard. But to see whether, if the same concept repeats next year, that is when you're giving the gate exam, okay, whether you will be able to answer that question, you should know, okay, they could have asked this to make it easier. At least if an easy question based on the same concept shows up, you should be able to answer that. For that, you should be able to identify what else can they ask. What else could they have asked? And in the hope that, okay, the hard question, okay, you recognize kind of, you keep on doing this process again and again. In the process, you learn that, okay, this is a hard question, I will skip. Okay, you read the question, oh, this is what you have to do. These are the steps you have to do. It's kind of hard. Okay, I'm going to skip this question. If they had perhaps asked this part, I would have done. Or you recognize they are only asking a part of that, which you know how to answer. Right? That recognition, identification of easy questions, known questions in the actual exam will easily come if you do this framing exercise for new questions. There's an exercise that I suggest everyone to do. So there are two sides of a coin. So is there an easy version? All the, these 4 things that you mentioned are easy. Is there a harder version? Okay. In real life, okay, quickly design an op-amp that will filter circuit that will give you this response. Design it. Give me the resistance value. If you are using capacitor, give me the capacitance values, all of that. That is actually harder version. Okay. So any question, there are easy versions, there are harder versions. Okay. In the worst case, they can give you 4 or 5 circuits and identify which one is the uh, appropriate circuit that will give you this response. 4 circuits, pick the circuit that will give this response. Okay. Similar, if not easier. Okay. Now, this is a general strategy on, how you should be actually practicing. Okay. I wanted to give you a couple of examples so that, okay, rephrase questions. What do you mean by rephrase questions? Should I change active tense to passive tense? Right. No. That's not what I'm asking you. Can you actually synthesize similar questions based on the same concept? Okay. And I wanted to, this is a nice, PYQ where I can show you multiple examples. In fact, a part of this process is, can we identify where they can set traps? Okay, we identify, okay, this question we can solve, but where can they possibly set traps? 4 options. One possible trap is, of course, the standard trap is, by changing the unit, of course, you're going to change the answer, right? Typical trap is this. If you're making a lot of silly mistakes, again, start learning, identify traps in questions. Typical trap. Okay, or for this question, they actually, they ask a easier version. They instead of h of s, they ask you for h of s inverse. Again, we tend to make mistakes. Right? In fact, give h of s, find the parameter in h of s. Use this use this point, actually one of this phase plot, to find a parameter. Find parameter in h of s. Right? So that's also another version. Let's have this in blue because find parameter. There is a parameter in h of s. What is the cutoff frequency there of sorts? Okay. So with this exercise, let's move on